Okay, now I want to go through this 2014 Emax paper 1. Okay, so one of your classmates asked this question to do how to do part A. So an object starts from rest and travel in a straight line. The distance traveled as meters is directly proportional to the square of the traveling times t seconds. So s is directly proportional to the square of the time. So the equation that you should write down is s equals to k t square, where k is constant. Okay, so how do we sketch this graph? You can see that this s equal kt square is similar to our y equals to kx square, right? So what do we call this kind of equation? We call this a quadratic equation. Okay, so a quadratic equation should be either happy face or sad face. So in this case, assuming k is a positive constant, so a quadratic curve will look something like this. So happy face. Okay, why is it passing through the origin? Because when t is 0, s will be 0, so it passes through the origin. Okay, so if I were to draw the quadratic graph like that, okay, it does not fit into the context of the question, because time cannot be negative. Time cannot be negative. So this portion of the graph we should erase off, okay? Because time cannot be negative. So we should erase off. So this is the graph s equals to kt square. Alright? So for part B, okay, so this is a quadratic curve. Make sure you draw a curve, not a straight line, because it's a quadratic equation. And then for the next part, in the first 4 seconds, the object travels 36 meters. So t equals to 4, s equals to 36 meters. So you sub inside the equation s equals to kt square. Your s is 36, t is 4. So 36 equals to 16k, k equals to 2.25. So answer is 2.25 t square. And calculate the time taken to travel 20 meters. So when s equals to 20 equals to 2.25 t square. T square equals to 8 over 9. So t equals to plus minus 2.98. Of course, time cannot be negative, so you take the positive time, which is 2.98 seconds. That's the answer. It's a 2014 paper 1.